Hi my friends, today we reopen this mechanism which was presented in my tutorial 178 because we want to apply the dynamic simulation for this mechanism. In fact, the question is, if you apply an input rotation here, is this output rotation equal in every moment with this one, or like at universal joint or gimbal coupling, which is not uniform. Let's see if this is uniform. When you rotate here 30 degrees, to have here a rotation of 30 degrees, and this to happen in every moment. But before, I want to keep your attention with this. You see, I don't use the mouse to make such movements and zooming. I received this gadget for testing from the Romanian company Radiant Consulting, and I am amazed at how smooth all the maneuvers are when I use it. In fact, this is a space mouse, as it is called, and you see it here. You use your left hand or the other hand, because it is symmetrical, to operate it. It looks just like this. The producer is 3D connection. For the moment, I want to show you some features by using the 3D connection trainer. You see, when you move the cap up and down, you move the model up and down. You can move it left and right as well, or zoom it, rotate it in 3 axes, as you can see, or combine all the 3 movements as you want to see the model modifying position and view. Coming back to the subject, I recommend you to watch again the tutorial number 178 in order to remember and be very familiar with all the components and constraints imposed on this mechanism. F6, and before anything, let's repair a mistake which I presented when I made the assembly. If we start the drive, we can see that this sleeve comes over the bottom part of the main shaft. So this is a mistake. Let's repair it by editing the stand, the extrusion, which has a sketch, extrusion 3, sketch 3, double click, and change this with 95. Okay, return. Everything is updated, and now the problem is solved. Good. I want you to know that when you are in the assembly environment, you can create extended names here by using options. Remember, we are in the assembly environment, so option, assembly, display component names after relationship names. Look here. Apply. Yes? And if you open and you are now in the part environment, you can apply the same option, but not on assembly, but to the part. Display extended information after feature name. Look here. Yes, we have more information about each feature. Good. This is good to know for you in the future. Let's go to the problem. Apply dynamic simulation. We received the same message because there are two over-constrained degrees of freedom. Now we have experience from our previous tutorial, number 179, about this problem. However, this time we'll use another solution and we'll continue without changing joints, since we are not interested in force. You see, all these joints are created automatically by converting the constraints in the assembly. This happens because this option is enabled. I make something interesting and different. I disable this. And to the question, maintain standard joints automatically created from assembly constraints, I answer no. Now look here. Okay, all the joints are disappeared and all the components are grounded. The first is grounded because we selected grounding of the body of the stand, and the other because there is no joints to create movement between them. Good. Next is to weld components which are a common part. For instance, this main shaft, look, it is selected here. I keep the key Control pressed and I select this. This is also selected. Right click and Weld Parts. Now we see here a welded group composed from these two parts. Nice. We have something different. Well, we can apply this to many other components. For instance, we can select the fork. This is the fork. Control pressed, lead, bolt, and we go back here, control, select the nut. 4 objects, 4 components are selected. Right click and apply Weld Parts. Good, another welded group was created. The last one is this one. Control, I select the lead, I select the fork and also the nut. 1, 2, 3, 4. Now weld parts. We have 3 groups of component welded. Now we have to create joints. To create joints, we don't go back to the assembly and somehow convert them here. No. In this environment of dynamic simulation, we use this tool, Convert Constraints. We have a dialog box which asks us to select 2 parts. I select this and this, the shaft and the bearing, and we receive possible mates: insert, which is enabled, and angle, which is not enabled. We like this combination, so we apply because we want an insertion here. Insert, apply. Next is between this shaft and the welded fork with the other components. We have here another insert, revolution joint, apply. Then the pivot and the fork, revolution, apply. Then the pivot with the 90 degrees shaft, apply. Then the 90 degrees, our sleeve with 90 degrees shaft, which is this, with the main shaft, apply. As long as we don't receive a message, these are okay, all of them. Let's go to the other end of the assembly, which is this output end. This is input, this is output. We select the shaft and the bearing, apply. We select the body of the shaft and the fork, revolution, apply. We select the fork and the second pivot, apply. And now when we select the other shaft of this mid part with the corresponding pivot, apply, we receive an over constraint. But reading here, construction may continue without changing any joints. However, care must be taken when analyzing reaction forces, since they are no longer unique. We don't intend to use forces in the next moment. We'll use only the movement. You see, my intention is to see that when we rotate the input shaft, we have the same rotation all the time to the output shaft. We can do this with dynamic simulation. Good. Let's take a look here. There are mobile groups and standard joints. One of them is with problems, but we don't care about this. Where is the problem? You see, we have now 2 chains. I want to see which are the chains. The first one is this left one with the stand, and the other one is the output with the stand. The mid shaft at 90 degrees is also selected. So the problem is here, but we don't have any information where is and what is. So we have to make investigations. Yes, we don't want to make investigations since we don't care about forces. Good. Now we look for the joint of the input shaft, which is the first one. To apply an imposed motion. You know how to do this, don't you? We study this joint by opening the properties option. The joint has only 1 degree of freedom. We select edit imposed motion. We select enable imposed motion and the graph. 1 second is the time, and I don't want 1 second, 0.25 seconds to be the start, the duration from 0 to 1/4 of a second. And here I want to have 50 rotations per minute. You can place this manually, rotation per minute, because normal is degrees per second. And what is the value? You see, 200 degrees per second. I didn't make anything. It was changed for itself. If you want to work with RPM units, you have to go here and open the more extension, and here input angular velocity in revolutions per minute. If you enable this, you will have that units. Okay, we don't do this now. This is the only imposed motion we place. And if we start the simulation, we'll see what happens. In a second, this is all it happens. Go back, construction, 6 seconds, and now we have a longer movement. Good. We are now in the front of our question. Is this movement identical with this movement? To verify how it is, we select trace, we select the point on the cylindrical face, this point, and velocity. It will be red. The trajectory will be red. Apply. We go to the other shaft, this one, and we place here velocity with another color. Apply. It's the same color. We can change the color. Okay. And now output grapher, which we know already. Traces velocities v, trace 1 and trace 2 v. One is blue and one is red. Which is which? The input is blue and the output is red. It is already drawn, and if we don't see here two curves or diagrams, we know that they are the same. Look, I disable this and we have only blue. This is the graph of input. We disable this. This is red. Yes, the two are identical, absolutely identical. Let's apply the movement again. Go back and movement. Everything is identical. That's all for today. Thanks for watching. Bye bye.